Going on now to topic 5 of chapter 4. This will be the last section we cover. We're dealing with inequalities in two variables and graphing them. A little review that I set up over here on the side is the inequality symbol for less than or greater than. When we graph them, since these points aren't included on the graph, we use a dotted or a dashed line, and that you pick out of your tool palette. If it's less than or equal to, greater than or equal to, you will use a solid line. And then in these inequalities, in addition to the line, you also have to shade the area where answers would be found. And the general rule is, if y is greater than or equal to, you shade above the line. If y is less than or equal to, you shade below the line. And we'll see this as we go on. And some of the key words that we'll be putting in these four statements: half plane, linear inequality, a test point, and vertices. So give that a shot. So looking at this is an example of a linear inequality because of the inequality sign, and that the exponents are just to the first power. Now, once you make a line, you are dividing your rectangular coordinate plane into a half plane where half of it would be shaded. Often, to determine where you shade, in addition to this rule over here, we can also use what is called a test point. If the test point that we choose, a pair of coordinates, are in or make the statement correct, that's the part we shade. If it's not correct, we shade the other part. And then if you end up with a polygon because of different points, the corners of the graph, and you'll see illustrations of this, are referred to as the vertices. Now here we have to place the x coordinate where x is, and that gives us a 2. The y coordinate where y is, that gives us a -20. And then we see if this expression or inequality is true. Well, this is going to be a -16. Is that less or equal to 5? And that answer is yes. Now, notice here they didn't quite have it in standard form. They switched the y term around. So y is 12 and x is 20. So this gives us a -44. Is that greater than 1? And the answer is no. Now what they're saying is, if this is your test point, where you put that point, that's the part you would have to shade. Now they're asking us to graph these lines, and notice it's sort of in the form of y equals mx plus b. So there's our slope, and there's our y-intercept. Now if there isn't a y-intercept, then it's 0. So for this one, it's going to be 0, and it's 1 over 3, so we're going to do run of 3, and rise of 1. And what type of line? A solid line. And then, where do we shade? Do we shade above or below? Well, a positive y is less, so we're going to shade below. All right, going on to this one. Our y-intercept is a -2, so it'll just fit there actually. And our slope is 1 over 1. So we're going to go over 1, up 1, over 1, up 1. Give me a little more room. And what kind of line? Solid line. Good. And where do we shade? Well, it's y is greater than. A positive y is greater. So we would shade above. And I kind of like that part in Math Lab. It has a nice bucket of paint that you can use. All right, for this one, notice it's in standard form. So a technique for this one would be to make a t-chart. That special t-chart for finding our x and y intercepts. So now if x is 0, y is a -8. If y is 0, x will be a 2. And we went over a lot of these in chapter 2. So 0, -8 is right there. And this is going to be 2, 0, which is right there. Now, what kind of line do we need? Well, it's only a inequality without the equal, so it's a dotted line. And I'm just going to sketch this in here. And you can see why sketching isn't too great. But now, where do we shade? Well, notice this is a -y is greater. So I know we're going to shade. I know where we're going to shade. But let's do a test point. We're going to put a dot right there. And the ordered pair is 0, 0. Now, do we shade where the ordered pair is, this test point, or do we shade the other side? All right, just try it. Here, x is 0, so this will become 0. Y is 0, that becomes 0. Is 0 greater than 8? Is that a true statement? And the answer is no. So you don't shade where this trial point is. You're going to shade on the other side. Now, I already knew that because if a -y is greater, a positive y is going to be less than. A -y is greater, that's not where you would shade. You shade where a positive y is less. That's under the line. In this next one, notice it's kind of in a funny form, so I'm going to transpose that. It becomes then a 2x. See, I have a little error there. That's better. So now I'm using my special t-chart because it's in standard form. If x is 0, y is a -2. If y is 0, x is a 3. And it's a dotted line because of the inequality sign. I have to determine where do I shade. Again, I'm going to use the test point 0, 0. So if this is 0, and if this is 0, is 0 less than 6? And the answer is yes, that's true. So we shade above. Now notice here we have a negative y is less. Can you see that a positive y would be greater? We'd have to reverse the sign, and that's what I have here. Okay, let's go on and solve number 11. Well, this one, the way it's set up, we just have a y inequality, and in a sense there are two of them. Here we're saying y, and let's just do the equal part. Y is equal to -3. Well, that line is a horizontal line, like so. And this one is y is equal to 4. That will be a horizontal line at 4. But now notice it's saying y is greater than that. So we'd have to shade in this area. And they're saying y is less than that. So we have to shade in this area. So this is our graph of this particular equation. Notice they are solid lines, two horizontal lines, and then the shading is in between those. Now, what can you imagine looking at these? Well, here these are going to be vertical lines. I think we could set it up right here at 0. There's one line right there. And then the other one is at 5. And it looks like they're both solid lines too. And we're going to shade between them, because they're saying x is greater than 0, x is less than 5. Okay. Now in this case they're asking us to use a graphing calculator, which we don't feature particularly. But if you have one, you put that in, and it should look like your y-intercept is a -4.1, which is right about there. And your slope is 1, so it's going to go through here at about 4.1. It's going to be a dotted line, and it says y is less, so you're going to shade underneath. Now over here, keep in mind we could use our x and y-intercept t-chart, and if x is 0, there's our y-intercept down there at 6. And this is almost a 4, a little less than 4, and it's going to be a solid line. But notice, a negative y is greater, so what would a positive y be? Less. Reverse the sign, so we shade underneath. Now we're going on to some examples in which we're going to graph two inequalities on the same graph, and we're looking for areas of intersection where they intersect. So let's set that up. Now here they're both dotted lines. Here our slope is a -1 over 1 at 0, so -1 over 1, that's the red line here. And this one's the blue line, starting there in that. And then I'm using arrows to indicate where we're going to shade. And we're looking for the region where we're going to shade both of them. And actually, we shade both of them in this area. And that is this particular graph. I'll do this one live for you so we can just review our technique again. So these are going to be solid lines because they're also equal to. Here my slope is 2 over 1. My y-intercept is 0. So 0 over 1 up 2. Over 1 up 2, over 1 up 2. I'm just giving myself a little more series of points to follow. And for this one, I would shade below the line. So I'm going to shade this way. And this next one is my y-intercept is a -3, which is right there. And my slope is 4, so it's over 1, up 4. So over 1, up 4. So this is my second line now. And I'm going right through there. And now I have to determine where to shade. Well, on my second one, I'm shading above the line. So for this one, the only place I shade then, and I'll put it in green, is right here. Again, using your bucket of paint is a little easier. And for these, I will do live because we're doing pretty good for the time. This is going to be a horizontal line, a solid line going through -3. So there's my line. And it says we're going to shade above this direction. And for this one, notice it's a little bit out of order here, so let's put it in order. My y-intercept is 2, it's going to be a solid line, and my slope is -1. So, change colors here. My y-intercept is 2, goes over 1, up 1. And there's my line. So we're going to shade below, and the part where they intersect is here. Now, again, some students have difficulty in this. So this idea of little lines indicating where they go on your homework log or wherever you're doing your calculation, and then when you put it into MATLAB. Okay, let's go on. I think a good technique for number 18 would be your X and Y intercepts, and let's check that out. So, looking at our examples here, in number 18, we see when we set it up, we actually have two parallel lines, and we are shading in between those parallel lines. So the use of my line tool was quite helpful in doing this. Okay, in number 19, it got a little bit of a challenge here. And we see this is our first one. Our y-intercept is -6. Our slope is 1, so it went there. This is our second equation, which is in blue. Let's get a nice blue here. And I did our last vertical line in black. Now, this is the shading area, and you see there is a corner point right there, or a vertice, and that looks like it would be a 5, comma, -1. Well, this is an interesting one they give us for example 20. As I say, if I did the t-charts, I get points like a 12 and a 10. There's no place on the graph. So I would have to cut these down by 2. But anyway, if I solved it by solving for y and putting it in slope-intercept, it still doesn't give me. So I had to extend this way up here, use another technique, and this is the area. And our corner points or vertices, I didn't quite get this one right because this point up here is probably off, but it looks like a 4.4. And this corner point would be 6, 0, and this corner point up here is looks like 0, 10. Anyway, or actually this one probably is yeah, this would be the corner point. There, there, and there. So this one would be 0, 6. Okay, well, this wraps this up. Again, this one is not a good example because they didn't give you the graph paper to do it with. Keep in mind, I also give a whiteboard lesson on this, and that's posted to YouTube just a little earlier down, and hopefully these are helpful for you.